Hey, everybody, and welcome back. Today, we are going to be talking about light
Yeah.
and color.
Light and color.
Yeah. So, I mean, you look around and you see colors and you see, the light from the sun or from a lamp or whatever,
Yeah.
but you don't think about what's actually going on there,
Yeah.
you know?
Right.
And I think that's what we're going to get into today.
Absolutely.
One of the most interesting things I thought, researching this is that light itself appears white. Right? Like when you look at the sun, you don't think, oh, the sun's, green or blue or red or whatever.
Right.
It looks white,
Yeah.
but it's actually all of the colors mixed together.
It is. It's the whole visible spectrum that we can see.
Wow.
All those colors combine together and they blend to create what we perceive as white light.
And so how does that happen? Like, how do all those colors become white?
Well, it's all about the wavelengths of light. So light travels in waves, and different colors have different wavelengths. So when all those wavelengths are combined together, they mix, and our eyes perceive that mixture as white.
Okay, so the different colors have different wavelengths and they sort of like all come together.
Yeah, they all come together. It's kind of like if you think about mixing paint. If you mix a bunch of different colors of paint together, you eventually end up with like a muddy brown color.
Right.
But with light, it's different. When you mix all the colors of light together, you get white.
Okay, so it's not like mixing pigments. It's like a different thing altogether.
Yeah, it's a different phenomenon altogether. And one of the best ways to actually see this in action is with a prism.
Okay, a prism.
Yeah. So if you take a prism, which is basically a triangular piece of glass, and you shine white light through it, what happens is the light gets split up into all its different colors, and you see a rainbow.
Oh, yeah, I've seen that.
Right. That's because the prism bends the light, and different wavelengths of light bend at slightly different angles, so they spread out, and you can see them individually.
That's why it's like a rainbow, because it's separating all those different colors.
Exactly. It's separating all those different colors based on their wavelengths.
Yeah.
And the shortest wavelengths, like violet and blue, those bend the most, and then the longer wavelengths like red and orange bend the least. So that's why you see that classic rainbow pattern.
So like the prism is separating it out so we can actually see those colors individually.
Exactly.
Instead of just all mixed up as white.
That's right.
So cool.
And this phenomenon of light separating based on its wavelength is called dispersion.
Dispersion.
Yes.
Okay.
So that's what's happening with the prism.
I mean, is that also why like the sky is blue during the day and then like at sunset it's like reddish orange?
That's a great question. And yes, it is related. It's all about how the sunlight interacts with the particles in our atmosphere. So during the day when the sun is high in the sky, the sunlight has to travel through a relatively shorter distance of atmosphere to reach us. And the shorter wavelengths of light, like blue and violet, they get scattered more by the tiny particles in the air, like dust molecules and other stuff. So we see a lot of that blue light scattered all over the sky, and that's why the sky appears blue to us.
Oh, that's so interesting. Okay.
Yeah. But then at sunset and sunrise, when the sun is lower in the sky, the sunlight has to travel through a much longer path through the atmosphere.
Okay.
And so those shorter wavelengths, the blues and violets, they get scattered away even more.
So they're just gone, basically.
Pretty much, yeah. They just get scattered in all different directions. And what's left are the longer wavelengths, like red and orange and yellow.
Okay.
And those are the colors that we see in those beautiful sunsets and sunrises.
Wow. So it's all about like how much atmosphere those colors are traveling through.
Exactly.
Wow, that's so cool. So we've been talking about like natural light, but what about the colors we see on like our phones and our TVs and computer screens?
Yeah. How do those work?
Are they actually emitting all those colors or is there something else going on?
That's a great question. And it turns out it's a pretty clever trick that those screens use. So they actually only use 3 colors of light: red, green, and blue. Those are called the primary colors of light.
It's primary colors of light.
Yes. And by mixing those 3 colors at different intensities, they can create the illusion of millions of different colors.
Wait, so it's like they only have those 3 colors and they're mixing them together.
Exactly.
To make all those colors we see.
That's right. So think about it. Your phone screen or your TV screen is made up of tiny little dots called pixels.
Okay.
And each pixel can emit red, green, and blue light.
Okay.
And by controlling how bright each of those colors is in each pixel, you can create any color you want. So if you want like a bright yellow, you would turn up the red and green light in a pixel really bright and keep the blue light low. Or if you wanted like a deep purple, you would turn up the red and blue light and keep the green light low.
Oh, wow. So it's all about like how much of each of those primary colors is being used in that little pixel.
Exactly.
That's incredible.
Yeah, it's a really clever system, and it's what allows us to see such vibrant and detailed images on our screens.
So it's not like they actually have millions of different colors.
Yeah.
They're just mixing those three really well.
That's right.
That's mind-blowing. Okay, so we've talked about, the light from the sun and the light from our screens. But what about like the colors of objects around us? Like, why is an apple red or a leaf green?
Yeah, that's another great question. So the color of an object isn't actually inherent to the object itself. It's all about how the object interacts with light.
Okay.
So objects absorb certain wavelengths of light and they reflect others.
Okay.
And the color that we see is the color that's reflected back to our eyes. So for example, a red apple appears red because it absorbs all the other colors of light except for red.
So it's absorbing everything but red.
Exactly. And it reflects red light back to our eyes, and that's why we see it as red.
So it's not like the apple is actually red. It's just reflecting red light.
Right. It's reflecting the wavelengths of light that correspond to the color red.
That's so weird to think about. Like, it's not actually the color we see. It's just reflecting it back.
Exactly. And it's the same for any other object. A green leaf reflects green light. A blue shirt reflects blue light, and so on.
Wow. Okay. That is very counterintuitive, but also cool, I guess.
It is pretty cool.
And this is where it gets even cooler, right?
Yeah.
Because some animals can see wavelengths of light that we can't even see.
Absolutely right. So our eyes are only able to detect a very narrow range of wavelengths that we call the visible spectrum. But there are other wavelengths of light out there like ultraviolet and infrared.
Right.
And some animals have evolved to be able to see those wavelengths. For example, bees can see ultraviolet light, which we can't see. And this allows them to see patterns on flowers that are invisible to us.
So they're seeing a whole different world, basically.
Exactly. They're seeing a whole different world of colors and patterns.
Wow, that's incredible. So we've been talking a lot about like the different colors and the different wavelengths and everything. And actually in the research for this, we came across a table that shows all the different colors in the visible spectrum.
Yes.
And shows like their wavelengths and frequencies and stuff.
Exactly. So it's kind of like a map of all the colors we can see.
Yeah, so maybe we could go through that table and talk about some of the interesting things about each color.
Absolutely. So starting at the shortest wavelength, we have violet light. Violet light has the shortest wavelength and the highest frequency.
Right.
And it's often associated with royalty and spirituality.
Interesting.
Next, we have blue light. Blue light is associated with calmness and tranquility. It's also been shown to have some interesting effects on our sleep cycle.
Oh, really?
Yeah, blue light can actually suppress melatonin production, which is the hormone that makes us sleepy.
So that's why they say don't look at your phone before bed.
Exactly. And then we have green light, which is the color our eyes are most sensitive to. It's often associated with nature and growth, and it's also used in night vision goggles because our eyes can detect even very faint amounts of green light.
Oh, that's cool.
And then we have yellow light, which is associated with happiness and optimism.
Okay.
Next is orange light, which is associated with warmth and energy.
Okay.
And finally, we have red light, which has the longest wavelength and the lowest frequency.
Okay.
Red light is often associated with danger and excitement.
That's why stop signs are red.
Exactly. It also travels further through the atmosphere than other colors.
All these colors, it's like a whole hidden language almost.
Yeah, it really is.
And we're just starting to understand it.
Yeah, there's still so much we don't know about light and color, but by studying it, we're learning more and more all the time.
So what are some of the cool things we've learned about light and color that have led to like new technologies and stuff?
Oh, there are so many examples. So understanding light and color has allowed us to develop things like fiber optic communication, which uses light to transmit data at incredibly high speeds.
Oh, wow.
And we've developed all sorts of imaging devices used in medicine and science that allow us to see things we couldn't see with the naked eye.
Wow, that's amazing. So like light and color, it's not just about like pretty rainbows and sunsets. It's like really important for all sorts of technology and stuff.
Absolutely. It plays a role in countless aspects of our lives.
That's incredible. It really makes you appreciate the world around us in a whole new way.
It really does.
And, it makes you wonder, like, what other things are out there that we can't see? We talked about animals that can see ultraviolet and infrared light. Like, what if we could see those wavelengths too?
Yeah, what would the world look like then? It's a fascinating thought.
Well, I think that's a great place to leave it for today. And next time you see a rainbow or a sunset or even just your phone screen, take a moment to think about all the amazing science that's going on behind the scenes.
Absolutely.
There's a whole world of color out there just waiting to be explored.